Good morning and welcome to your science lesson. For this lesson you need the usual equipment. I would recommend that you have a calculator. All of your notes should be made in your homework book and you should be setting them out as you would in a lesson. You should have already completed the low stakes quiz. If you haven't, pause the video and complete that now. It is also important that you have registered. So if you have not yet said that you are here, go back to Google Classrooms, scroll down to registrations on the classwork page and sign yourself in to science. When a solid turns to gas, that is sublimation. Specific latent heat is the energy needed for 1 kilogram of a substance to change state. For example, going from solid to liquid, ice melting to water, water to gas, water boiling to cause water vapor. The total amount of the kinetic energy and potential energy of all the particles in a system, internal energy, because it's the energy inside the molecule or the atom, contains antigens to trigger a low-level immune response, that's a vaccine, and a medicine that only has psychological effects, well, that's a placebo. Excellent effort if you've got 5 out of 5. Don't forget, you've still got an expectation to do your homework. So today's title is density, and we are starting a new topic. So we've come off quantitative chemistry, and we are now looking at the particle model of matter. Can you make sure you've underlined the title with a ruler and that you've put the date in the top right-hand corner? Our learning objectives for today. Recognize or draw simple diagrams to model the difference between solids, liquids, and gases, remembering that solids, liquids, and gases are the states that we can have particles exist in, and explain the differences in density between the different states of matter in terms of their arrangement of atoms. We can talk about molecules, so molecules can be in liquid state, molecules can be gases. Recall and apply the definition for density, because you are not given this in the exam. When you sit your GCSE, you get given a physics equation sheet in the physics exams. The equation sheet will give you some of the formula that you need to know, but most of them you actually need to learn by yourself. So you need to know what the formula for density is. Remember, when you're learning formulas, it's just as important that you know the units. And we should be able to use a variety of models to solve problems, make predictions, and develop scientific explanations. Quite a lot going on there. Definition. Density is the mass of a substance in a given volume. So a tree with a mass of 1,000 kilograms has a greater mass than a 0.01 kilogram steel nail. In the same volume, though, there would be a greater mass of steel. Steel has a greater density than wood, and we're going to find out what that means over the forthcoming lessons. A cork floats and a stone sinks. The cork floats because it is less dense than the water it is floating on, and less dense than the stone. The stone sinks because it is more dense than the water it is in, and more dense than the cork. So the stone has more mass per volume than the cork. I'm going to give you time to just read that again and make sure that you're happy with what that says. When you're happy with what that says, you might want to make some notes. In your books, please, can you explain, using density, why a cork will float but metal will sink in water? Some of you will be able to crack on and do that without any further assistance. Others of you might wish to have some sentence starters. The sentence starters that you could use are here in the box. This should take you no more than 3 minutes. Using the terms density, you should have said that a cork will float because it is less dense than the water. Similarly, you should have said that the metal will sink because it is more dense than water. And a cork is less dense than the metal and the water. So keeping all of that in mind, and please make any purple pen corrections that are needed. On the next slide, you're going to correct what's wrong. Copy out the sentences, take your purple pen, correct it. 3 minutes. The cork does not float on water because it is lighter. It floats on water because it is less dense. The stone sinks in the water because it is more dense. It is really important when we are discussing density that we are talking about density and not weight. We have a formula that we need to learn for density. Mass is density times volume. So if I want to work out the mass of a material, I multiply its density by its volume. I've mentioned MPV, not MP3, because if you learn MPV, M equals P times V. I find that's really useful to help me remember how to calculate mass using density and volume. I would make sure you've got that written down with the units. More usually, though, we calculate density, and density is mass over volume. Same units, same letters to symbolize the terms, but this is more how I'd expect you to use MPV. I just find MPV much easier to remember. And our last component of the definition, volume. So to calculate volume, I divide the mass by the density. The units are important because if I use the wrong unit, I will get the wrong answer. So you must remember that density is in kilograms per meters cubed because it's volume, so it's meters times meters times meters. The mass is in kilograms, and obviously the volume, meters cubed. You do need to learn it. If aluminium has a density of 2,700 kilograms per meters cubed, I can calculate the volume of 135 grams of aluminium. The first thing I need to do is convert the mass to kilograms. There are 1,000 grams in 1 kilogram, so 135 grams divided by 1,000 gives me 0.135 kilograms. Now that I know my mass, I can divide it by the given density. So 0.135 divided by 2,700, put that into your calculators. Some of your calculators will come up with the standard form. Brilliant. You need to be happy using that. Others will give you 0.00005 meters cubed. You would get a mark for that answer, but you're more likely to get it wrong because of the confusion of the zeros. Let's just take a look at this standard form. The 5 is 1, 2, 3, 4, 5 places after the decimal point. And when I'm using standard form, the value has to be between like 0 and, well, up to 10. It can't be greater than 10, because if I've got 10, I can just move it up another decimal place. So 5 times 10, because it's in the decimals, it's going to be minus, and then remember how many places we said? 1, 2, 3, 4, 5. So 0.00005 can be written as 5 times 10 to the minus 5. If you need more help with standard form, there is Corbett Maths, there is Hegarty Maths. You also have some fantastic maths teachers. Let's use them. I would like you to have a go at these 9 calculations. Nine calculations. It's most probably going to take you about 12 minutes. Feel free to set a timer. Think about your layout. Think about how you are recording this information. In a maths exam, in a science exam, they're going to be giving you marks for showing you're working out. How are you going to show you're working out here, please? Get your purple pens ready. Here come the answers. Calculating density is this first equation. Density equals mass over volume. The first two are straightforward because the units are straightforward. They're in kilograms and meters cubed. So I take the mass, 1.2 kilograms, I divide it by the volume, 0.5 meters cubed, and the answer I get is 2.4 kilograms per meter cubed. Tick it if you got it right. Give yourself a mark if you did 1.2 divided by 0.5. This time the mass is 185 kilograms, and I'm going to divide it by 8.5 meters cubed. Using my calculator, because I don't need to make life difficult, the density is 21.76 kilograms per meter cubed. The next one's a little difficult because it's 25 grams. Remember, 1,000 grams in 1 kilogram. So I'm going to divide the 25 by 1,000 to get the value in kilograms. That gives me 0.025, and I divide that by 0.25 meters cubed. That gives me 0.1 kilogram per meter cubed. Total out of 6, did you get all 6? If you did, well done. If you did not convert the mass to kilograms, you'll get a method mark, but you will not get an accuracy mark. The next one was to calculate the mass. So to calculate the mass, density times volume this time. So the first one, nice and straightforward because I've got kilograms and meters cubed. 450 kilograms per meters cubed times 2 meters cubed gives me a mass of 900 kilograms. A block of wood with a density of 5 kilograms per meter cubed and a volume of 0.3 meters cubed, that gives me 5 times 0.3, which equals 1.5 kilograms. For part C, I've just made you have to work out a volume because it's a useful skill to have. You're learning it in your GCSE maths, but you should also be able to do it here. So if I've got a block 2 meters by 3 meters by 1 meter, the volume is all those numbers multiplied together. So that's 6 meters cubed. The mass is 6,300 kilograms per meters cubed. So 6,300 times 6 is 37,800 kilograms. Again, if you can, write it in standard form. You're less likely to make a mistake with those zeros. 3.78 is 4 places beyond the decimal point, so it's 3.78 times 10 to the 4. 10 to the 4 means 10 times 10 times 10 times 10, which would be 10,000. So 3.78 times 10,000 would give me 37,800 kilograms. Again, did you manage to get 6 out of 6? You can have a bonus one if you got the volume right. If you used an incorrect volume, again, you wouldn't get the accuracy mark, but you would get a calculation mark, a method mark. Calculating the volume. This time you were using volume equals mass divided by density. So a block of titanium with a density of 750 kilograms per meter cubed and a mass of 1 kilogram. So 1 divided by 750 gave me 0.0013, which is 1.3 times 10 to the minus 3 meters cubed. A block of tin with a density of 240 kilograms per meters cubed, apologies for not rectifying that 3, and a mass of 5 kilograms is 5 divided by 240, which equals 0.02 kilograms, or 2 times 10 to the minus 2 kilograms if you wish to use standard form. 1,500 kilograms per meter cubed and a mass of 50 grams. Well, 50 grams is 0.05 kilograms. Remember, you divide it by 1,000. So 0.05 divided by 1,500 gives me 0.000033. I'm not going to give that as my answer. I'm going to write it as standard form, 3.3 times 10 to the minus 5. Again, if you've got all of that right, definitely give yourself 6. Remember, you only get a method mark if you did the right method with the wrong numbers. And hopefully you've all got that. That's something you can easily practice, but you need to be able to do it, and you need to be confident rearranging that equation. Right, we have many practicals to calculate density of a regular solid. So if I've got a cuboid or a cube, I will just measure the dimensions of the solid. I will calculate its volume. Remember to do that. It's 12 times 8 times 14. So I take all three values and multiply them together. I then put the mass on a scale, the block on a scale to get its mass. And then using my calculation, I can work out density. Nice, straightforward. A method is worth knowing though, because it does occasionally come up as a practical in the exam. So my volume for this cube is length times width times height. Remember, it needs to be in meters, so I have to convert those units. Convert the units before you make the volume, otherwise you can make life a bit harder for yourself. And then if the mass is 1 kilogram, then density was 744 kilograms per meters cubed. Can you record the method, and can you just put an example in your notes? Another example you could be asked for is to work out the volume of a cylinder. Again, you're measuring the dimensions, you're calculating the volume. You then need to know the mass of the solid by putting it on a scale in kilograms, and then you can calculate the density. Again, we've got the wrong values here to work out the volume. Volume of a cylinder is pi r squared h. So you've worked out the area of the circle and then you times it by the height. Something you do need to know for maths. So pi times 0.06 squared times 0.08 gives me 9 times 10 to the minus 4 meters cubed. So if the mass is half a kilogram, then the density would be half a kilogram divided by 9 times 10 to the minus 4, which gives me 555.6 kilograms per meter cubed. I gave 1 decimal place because the mass was in 1 decimal place. That could be rounded up. That would not be a problem. Have a read of the slide. You can see from the picture that the density of the solids and liquids is much greater. Look how tightly packed they are. There are many more particles in that volume for both the solid and the liquid compared to the gas. They're closely packed. Much more closely packed in the solid. It's a very regular arrangement. Whereas with the liquid, there is still some possibility of movement, but there is a lot of mass in that small volume. In gases, the particles are able to move wherever they want to go. They're moving in random directions at great speed. They can take up as much space as they are allowed. So in the room that I'm currently sat in, there are gas particles whizzing around all over the place, taking up as much space as they can. If I then took the ceiling off, they'd have the next floor to fill, and they would just keep filling the space that they're in. Liquids will also fill the container that they're in, but they can only fill it like at the bottom. So if I filled the room with water, it would fill with water. But if I drained some of that water out, it would only fill water up to a certain volume because the particles are weakly bonded. Here is your fluency. This should take you 6 minutes. At the end of the 6 minutes, I would like you to take a photo and submit it to Google Classrooms. Now that your lessons are on Google Classrooms, you should be able to upload work. If you cannot upload work directly to Google Classrooms, can you please send me the photo via email? awalker@gloucesteracademy.co.uk. One last thing, just double check those units.